I'd like to take a few minutes to enjoy discussing with you the concepts of sniffing from a hacking and attacking perspective. And this will set the framework for us for a few subsequent nuggets where we'll take a look at specific attacks and what we can do as countermeasures to protect against those attacks. It was back in the early 90s. I was at Paramount Pictures and we were troubleshooting a client-server application. And as it turned out, we discovered what the problem was by putting a protocol analyzer and sniffing the traffic between a client and the server that it was communicating with. And the process of capturing and monitoring all of the packets or frames that are coursing through a portion of the network is referred to as sniffing. And sniffing is kind of the network version of a wiretap on a traditional phone system. And one of the unfortunate things at many companies is that switch ports, which have cables that connect out to offices and other locations in the building, many times don't require security. So a person can plug in virtually anything into an RJ45 jack, and then through the horizontal run that connects it to the wiring closet, have connectivity to the network. In more secure environments, they might use something like 802.1x, which is going to authenticate the user right there at the switch port before the switch allows other traffic to just flow through that port. But as I mentioned, not every company is using 802.1x, and not every company has taken the steps to protect unused ports. Now, regarding sniffing, there are two basic types. There is active sniffing, which is what we're going to see most of the time on modern networks, and we also have the option of passive sniffing if we're using a network that's using technology from like 20 years ago. And here's why. If we have a hub, and then we have all of our computers tied into this hub, the hub takes every single bit of information that's sent by, for example, computer A that goes into the hub, and the hub forwards it out every single other port. So the attacker on any port on a hub can passively just sit there and have access to all of the frames that show up. So let's say the hacker is this computer right here with an H. Now what the hacker might do is then tell his network interface card to run in promiscuous mode. See, by default, a network interface card isn't simply going to take every single layer 2 frame it sees and pass it up the protocol stack. Instead, it's going to take layer 2 frames that are destined for a broadcast address, which is all Fs. And there's 12 of them there. 12 Fs is a layer 2 broadcast address. And so when an Ethernet card sees that, it'll say, oh, this might be for me, and it'll pass it up the protocol stack. Or if a frame shows up and it's destined to the actual layer 2 MAC address that's built in to that network interface card, the Ethernet hardware address, the protocol stack will also pass that up the protocol stack so that the network layer and transport layer and so forth can be processed by the computer. But what a traditional card will not do, it will not take a frame that's destined to, for example, A, B, C, D, 1, 2, 3, 4, 5, 6, 7, 8. If that's the destination address, if that does not match the hardware address, the built-in MAC address on the Ethernet card, that's normally where a network interface card will say, nope, we're not interested, that's not our address, we're just going to discard the rest of that. Unless the attacker puts his network interface card into what's called promiscuous mode, which is kind of like loose and easy, like, hey, I don't care what the layer 2 address is. If I'm seeing the frame, I'm passing it up the protocol stack. So if this computer H right here is a user's machine, let's say it's Linux, we could do an ifconfig-a command, and it would show us in the output that it's in promiscuous mode. Or if the user was clever enough, there may be a rootkit that has been installed on that computer that has replaced the ifconfig command, so that when a user types in ifconfig-a, instead of getting the normal output, it's given some bogus output that hides the fact that it's in promiscuous mode. So going back to our original concept of types, if a network is using hubs where the frames are forwarded to every other port, we can refer to that as passive sniffing. And now, a newsflash. If we're running a current network, we're very likely using these layer 2 switches, which make forwarding decisions based on layer 2 addresses, the MAC addresses. And in that case, if computer 1 is talking to the printer, the traffic is going to go directly between the printer and computer 1. The layer 2 switch is not going to forward those frames to every other port in the environment. And that's one of the benefits of a layer 2 switch. The frames only go where they have to go. And in that case, the attacker or hacker, if he wants to start eavesdropping on other people's conversations, has to do something active in the network to get those frames forwarded over to the attacker's interface. And we'll have several nuggets on several types of attacks, but let me give you a brief overview, because that's where we are in the sniffing overview nugget on those types of attacks. We have MAC flooding. MAC here representing media access control, where the attacker sends so many frames into the network with different MAC addresses, bogus spoofed MAC addresses, that the switch can't keep up with it and starts forgetting where everybody lives. And as a result, every time it sees a frame, if it doesn't know where that frame lives, what port it's off of, it considers that frame an unknown and it forwards it to all the other ports, very similar to a hub. That's also sometimes referred to as a CAM table overflow attack. CAM representing content addressable memory. We'll have a separate nugget just on that. There's also several flavors of DHCP attacks, where the attacker introduces a rogue or bogus DHCP server, handing out the incorrect default gateway, which then causes packets and their respective frames to be forwarded over to the attacker's machine, so the attacker can be a man in the middle and have access to see each and every packet. There's also ARP poisoning, address resolution protocol poisoning, which could cause computer 1 to believe that the layer 2 address of its default gateway is the layer 2 address of the attacker, and frames are then forwarded to the attacker's machine first, so that the attacker can once again see those packets and those frames on the network, where otherwise he shouldn't have the ability to sniff those packets and frames in the first place. There's also DNS poisoning. DNS is probably one of the most popular applications that's used on the internet today to resolve names into IP addresses. And if we can poison the DNS tables, either in the cache on the computer, or we can poison a local DNS server, or we can poison a DNS server on the internet to feed the incorrect IP information when a client makes a request to resolve a name to an IP address, that can cause a diversion or a redirection of the client's packets. Instead of going to the real web server or the real site, those packets instead are now going to the attacker, who now has the opportunity to sniff those packets. Now, if all of our communications were encrypted and an attacker is eavesdropping on our traffic, it may not be a big deal. However, protocols like HTTP, Telnet, there's a lot of email apps that can be used without encryption. FTP is another application that uses plain text without encryption, and there's many more. And if a user's password is being used in any of those plain text protocols and the attacker has eavesdropped on it, the attacker now has those passwords as well. So going back to types, there's also, besides active and passive, we also have the implementation of a sniffer. Is it done in software like Wireshark? And in this course, we've taken a look at some outputs from Wireshark. And for more training specifically on Wireshark, check out that course in our library here at CBT Nuggets. And Wireshark, when we run that on a computer, that trains the network interface card to go ahead and operate in promiscuous mode. And that way, every frame that is forwarded to this machine running Wireshark, because it's operating in promiscuous mode, it can pass it up as well as provide analysis by the user running Wireshark to look at the details of those packets. And Wireshark, very similar to other software-based protocol analyzers and sniffers, uses something called WinPCAP. And among other things, it's WinPCAP and its libraries that are allowing the network interface card, when it receives frames, to go ahead and simply pass it up the protocol stack instead of just saying, oh, that's not my destination layer 2 address, I don't care. With WinPCAP installed and the interface operating in promiscuous mode, that frame and the subsequent packet and segment that are carried in that frame can be stored and analyzed by the computer running WinPCAP. Another example of a software-based sniffer would be Snort, which is a pretty amazing tool. A few years ago, Cisco made an acquisition which included Snort, so they're leveraging some of that technology in their products. So like Wireshark, Snort could act as a sniffer on the network. It's also capable of capturing and logging those packets. And it could also, with the right configuration, be used as an intrusion detection system, looking for specific signatures and behaviors, and then firing off warning shots when those are seen to bring those to our attention. And back in the early days, we're talking about like 20 years ago, when I first started using protocol analyzers, they were hardware-based, where it was a physical computer with dedicated hardware for that purpose, where we would plug it into the network and they could analyze the traffic for us. So let's imagine that you and I want to do some sniffing for legitimate purposes, and we want to analyze all the traffic that's coming from computer 2 that's coming in on this port, on the switch. Now, one option would be we could run a software-based sniffing application like Wireshark with its PCAP right here on computer 2, or if we had the correct switching components in place, we could set up mirroring and monitoring on that port. So let's say that's port number 2 on switch 2. What we could set up in a Cisco environment anyway is called SPAN. And that's an acronym that stands for Switched Port Analyzer. Think of it as a fancy way of spelling mirroring. And when we set up our SPAN sessions, we can indicate that we want to take all the traffic that's showing up here on port 2, and we can replicate that or mirror that to another port. So let's imagine that here on port 3, we have our computer, the administration computer, that's running Wireshark. And that's on port 3 that it's connected to. So in our SPAN session, we could go ahead and train the switch to take all the traffic that shows up on port 2 and replicate it or mirror it over to port 3, at which point it would show up in our computer, which is running Wireshark. And with WinPCAP installed, it's allowing us to go ahead and store and analyze all of those packets, even though the layer 2 addresses aren't specifically destined for computer A's MAC address, the WinPCAP in promiscuous mode allows us to bypass that. Now, one of the tricky parts is it's not always easy to identify that a malicious individual is doing eavesdropping on our network, because they're going to be doing the attacks, such as CAM table overflow attacks. And so unless we have the appropriate precautions and safeguards in place with features like DHCP snooping and dynamic ARP inspection, now even though the detection of a quote-unquote sniffer on the network is not too easy to do, there are a few things that we could quote-unquote try that might reveal whether or not a port on the network or an interface on the network is running in promiscuous mode. One is we could send a ping request. Now ping is pretty innocent. So let's say that this is our S machine for suspect, and let's say that this is our administration machine right here that we're doing the testing from. So we're the admin machine, there's the suspect, let's put a cable between them. Or if we want to put in a switched environment, we could do that as well. And let's say our address is 10.0.0.5 and the suspect is 10.0.0.20. And let's say our MAC address is all A's. Let's just say there's 12 of those, and that the suspect's MAC address is all B's. And let's also, for brevity, just assume that those 4 B's represent 12 hexadecimal characters, which are all B's. So if we craft a ping packet and we send it to 10.0.0.20, but we send it to a layer 2 address, let's say CCCC. Again, we'll say that's times 12. Assuming that the switch or this device between us doesn't yet know where CCC, etc. is, the switch would consider it an unknown and it would forward it to all ports. So if we send a packet to ping 10.0.0.20 with the incorrect MAC address, so the switch floods it so the suspect sees it, if the suspect responds back, that means they're not paying attention to the layer 2 address, and that they simply passed it up the protocol stack, where at layer 3, this computer said, oh, that's my address, 10.0.0.20, I'll respond. That could be an indicator that the port on the suspect machine is running in promiscuous mode. There's also some scripts that we can run with Nmap, which in the results of doing our scans with Nmap could inform us that based on how that system responded, whether or not its interface was in promiscuous mode. In this nugget, we've discussed some basic types and concepts regarding sniffing. And in the next few nuggets in this course, we'll take a look at some specific countermeasures against active sniffing attacks that we can implement in a Cisco-centric switching environment. And I look forward to seeing you in those nuggets. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.